So a quick overview of the original code, so the Doom 3 idTech 4 code. It was released GPL v3 with some additional terms there on November 22nd last year. It was without the CarMax reverse depth fail shadows, so naturally that was the first patch that I wrote to put that back. So it's GL1 and requiring some extensions. X11 GLX, it's quite an old engine, it's 8 years old. Surprisingly, it still stresses GPUs pretty well even today. So yeah, that's a good thing. There's multiple backends available in there, so like NV20, NV30, CG backend. The ARB2 backend is the most advanced one that we use, the ARB vertex buffer object extension when it's available, or otherwise it will just fall back and use virtual memory, which is a lot slower, of course. And then a quick overview of Dante. So it's OpenGL ES 2.0 using EGL. GLSL is the primary backend. I have the ARB2 backend still enabled in there, but that is of course compiled out when it's been compiled for ES2. So all of the new extensions are requirements. I'm not concerned about doing backwards compatibility too much there. One problem that I ran into was that the ARB vertex and fragment shaders, vertex and fragment programs are not licensed under the GPL v3 or later. So I had to do, clean room programs written in GLSL. And I added a few things there, so the Phong rather than blend Phong shading model, which gives some quite nice results. That's of course quite a lot more computationally expensive because we have an extra dot product and a reflect operation in the fragment shader. I can do this half Lambert lighting there, which I'll show on the next slide. So that anyone who's played Doom 3 will probably, complain that, well, the game's too dark. That would help. So, yeah. Okay, actually, the projector is not helping my point here. I'm sorry.
Maybe we can turn off the lights.
Yeah, that would be good if somebody can turn those off. But yeah, you can kind of see that the dark shaded areas are a little lighter shaded there. This is because instead of doing a lighting model where we're going from -1 to +1, we're going from 0 to 1, so it's squashing that range a little bit. But it can also look... okay, yeah, the projector messes this up really badly. Hopefully we can get the picture-in-picture thing going. But it can also look really bad, as in this example, where it looks sort of over bright. So anyway, that was my sort of quick introduction. Now to the optimization and performance problems. So on Mesa we really have no great tools for performance analysis. We have some things. We have, at least on Intel GPU top, and this is basically, if you've used the system top, it's the same kind of thing. You get the GPU is doing 80% usage there, but nothing at a per frame level. So it's okay for a rough estimate of your GPU load, but it's not going to give you any more information than just going in there and say, like, disabling a whole bunch of stuff in the fragment shader and realizing that, oh, my fragment shader is too expensive. Also, the output is pretty much unusable for anyone who hasn't read Intel GPU internal document, well, not internal, but hardware documentation. And game developers or even OpenGL application developers don't want to go and read some hardware specific documentation to figure out why their application is slow. They just want to know that, okay, my vertex shader is too expensive, or my fragment shader is too expensive, or I'm doing too many texture lookups, or whatever the case may be there. So this is what Intel GPU top looks like. This is running just GLX gears. I know, not a benchmark, but just a quick and dirty example to show something running on the GPU. If you're a game developer looking at this, you'll probably have no idea what's going on that. So it's not a very good tool. So we need to have better debugging and analysis tools, especially if we want to have game developers coming over and, you know, porting their stuff onto Linux. There used to be a tool by GRemedy called GDebugger. And they were acquired by AMD. The version before AMD used to kind of sort of work with Mesa with a bit of hacking and LD preload stuff. Now the new AMD version, of course, only works with FGLRX, their proprietary driver. So a combination of those factors, those three factors, make it basically an unusable tool for me. Yeah, and all of the other graphics vendors have similar performance tools that are actually quite good. We don't, unfortunately, have anything like that for Mesa, but we really should. This is something we should spend time and develop on. So this is a screenshot from the newer the AMD version of GDebugger, and here you can see that yeah, this one is of course probably memory limited from the graph there, and this is something, it's not so fine granularity as Intel GPU top, where you have all of the execution units listed there. But I think this gives a better idea to developers of what is actually costing them, where they are being hurt in terms of performance. So I think this is something that we should have, ideally. So the Linux kernel perf system. This was something that I kind of stumbled across when I was looking at CPU profiling and finding out that OProfile didn't compile. So I stumbled across this. And I won't go into and read the whole slide here, but the main thing that caught my eye was per task, per CPU, and per workload counters. The source code annotation, obviously that doesn't apply so much for GPUs. I don't know, maybe it's possible to do something with GLSL shaders there, but that's much further down the track. So I thought, well, if we can do this on the CPU and give good results for the CPU performance counters, well, why can't we extend that and do it for GPUs? So perhaps looking at the possibility to hook into DRM and the perf system, and basically taking those counters that we saw on Intel GPU top and bringing them over. Bringing them over so that they will be available from the perf system. So then you can have these nice tools, perfstat, perfrecord, perfreport, annotate, top, etc., and be able to fetch those counters and get output from them. Then the next step on that would be to do this on a per frame basis. So for that we would need some cooperation with user space. So some way to let the perf system know that this is the end of a frame, without doing something silly like GL finish or causing a GPU stall. So we could do that. Most GPUs have some sort of scratch register, unused scratch register, that we could write some magic value into and tell it that this is the end of the frame. We could do this at swap buffers automatically if the application doesn't support any of the extensions like the gremedy frame terminator. Yeah, so that can be done fairly easily. Then a user space debugger, so a separate process, can then read from the perf system and the kernel all of the data that it wants to, and display that as some interactive GUI. So for example the gremedy solution there, or generate some HTML report or ASCII art if you're really into the Intel GPU top thing. And this is very much like hand waving at this point. I have no prototype implementation, no code, nothing. I'm just hoping to get the idea out there that this is something that we should have and something that is important. So Mesa is also able to provide these nice debug hints. Unfortunately it's not implemented so well now, at least not on i965. Sorry, am I in the way? So there was one bug that I ran into. What Doom 3 or Dante will do is, instead of taking the hit and doing a state change to disable the SUSE test, it will just set it to the same size as the viewport rectangle. So that effectively disables it without disabling it. So it does take about 20 dwords if we want to actually emit the code to disable this as a test. I haven't yet investigated whether this would be, whether we would actually get that 5% performance gain or not. But yeah, so I think it would be useful to try to sync these perf debug hints with the perf frame data coming from perf. I'm not quite sure how we would do that. Maybe doing some emitting some frame counter token on each perf debug printf, and yeah, that could be matched up with the data coming from the perf system and the kernel. Yeah, so we currently don't output even to arbdebug output, which is really bad. That's something we should fix soon. And this will work basically as long as the debugger and the application being debugged are in the same context, the same GL context. We would need some inter-process communication if it would be, if the debugger will be a separate GL process than the GL process being debugged. So another bug that I found was in GLX versus EGL. This is running exactly the same time demo, so the demo 1. It runs quite a bit faster. You can see 33.3 FPS on EGL and 45.5 FPS on GLX. And that's basically because we have that nice fix me there to check the VBlank mode. So we should fix that. Yeah, so this went kind of quicker. If anyone has any questions, just jump in and yeah. So the bottom line is really that we need to have some better performance analysis tools, especially if we want to get game developers and you know, even OpenGL application developers like CAD and 3D rendering stuff. If we want to get those developers coming over and supporting Linux, then they want the same kind of feature parity as they would have on Windows. So Intel has also done some optimization work for Left 4 Dead, and there were a lot of good things that came out of that. So that was Eric, Ian and Ken going to Valve's headquarters in person. Obviously that's possible for Valve. They can afford to fly those guys out and do that. Sorry? Oh, you drove there. Okay, well, you know, but it's still not possible for some independent game developer to do that. So yeah, I mean, in summary, the performance tool is never going to be as good as having experts come in and go over your code line by line, analyze everything, figure it all out. But they can still be very useful, I think. And I think this is something that is worth taking the time and investigating and hopefully developing. Whether I can get approval from Intel or not to start working on that, or somebody else works on it, yeah, that would be a good thing. So if there are any questions, comments, suggestions, yelling.
All right. So there is a new tool being developed. On the debugging side, you've probably heard of API Trace.
Yeah, I have.
So there's some work going on now to build profiling tools using API Trace's framework. So there's an API Trace command you can run to replay a captured trace. And this is something that makes your trace not representative, but you can replay a captured trace. It puts ARB timer queries around each drawing call and tracks which shaders are active during those drawing calls, logs it out to a file. And then there are a couple of tools available for analyzing those results. So you can see which of my shaders am I spending all of my time in. And there's also, I was trying to look up where the tool was. I was going to show it off. But there exists some sort of tool for showing you an actual timeline of the execution of your program and the execution of your actual GPU commands later on, all in a nice visualization. This looks a lot like what people on closed source platforms are using for their debugging of performance issues in games. It's not as good yet because we don't expose any of those interesting other counters like how much memory bandwidth was used or you know, how many texturing calls there were. Just because we don't know how to get
things
them out
like
of the hardware.
cache misses and that kind of thing. Yeah.
We have those counters on Intel for Iron Lake. We need to go implement the extension for that. We don't have the counters for later hardware because it gets more complicated. But yeah, basically the tool is getting built. And the remaining big problem with the tool is, of course, that you're running a captured trace, not the actual application itself. So you get all sorts of, you know, interference with your results. So we've been talking about we need to go and build a shim GL that would insert around all of your drawing commands these various profiling hooks. So you would be sitting in the same GL context just by intercepting GL and doing things behind the user's back. Yeah, which is how the other platforms tools work.
Yeah, I guess that is another way of doing it. But I still think that it would be valuable to you know, have the kernel tracking these counters using the perf system in the kernel.
Yeah, the issue I see there is how do you track that back to your actual information about the GL that you as a user needs to see, right? Because I'm not going to be running all the GL commands through the perf framework, I don't think.
No, but if you have this frame terminator there, then you know that at least you have one frame granularity. So you don't have per GL command granularity, but
yeah, which
per
is
frame.
It doesn't really help you then figure out what in my frame am I doing wrong that makes this hard. The advantage of the shim-GL approach is that you have all of the information available to you. Anything you want to hook, just hook that in and do your work and dispatch down.
Okay, well, maybe I need to talk to you a bit more about this then. So I think there is some time left, so I can run a demo if you want. And yeah, I'm seeing some nods and some grins out there, so okay. So this is, yeah. So I can run it through a time demo. And of course you can see up there the yeah, this is the 5% performance win that I was talking about. It's a possible 5%. Whether it really would amount to 5% or not, I don't know. And there are some shaders here that are defaulted because I haven't implemented those as GLSL shaders yet. This is probably really bad with the lights on. Marginally better. But okay, it is a dark game, so. This is running with the EGL backend. So it should end up being somewhere around 30-something-ish FPS at the end. Yeah, so 31.3. It would be a little bit faster if I would run it again, because now it's cached all of the media assets. But yeah, that was about all I had for the talk. So if there are any more questions or comments or yeah. No?
I don't know if I didn't pay attention, but which hardware exactly and which driver are you using?
So this is running on the i965 Mesa driver on Sandy Bridge.
Okay, so you don't use Gallium?
No, it's
okay.
not running on Gallium.
Yeah, there were a few drops to say about 3 frames per second. So is this due to the presentation mode, or do you still have some issues in some of the lighting scenes?
Sorry, could you?
So some of the scenes where the frame rate was dropping down to, say, 3 frames per second or even less. I guess this is just an artifact from presentation or something else.
No, I think that actually is a real performance issue that I haven't been able to debug yet, or had time to debug.
Mm-hmm.
But I can run the demo again, and it should be a little bit smoother, because what will happen the first time it runs through the time demo, it will be loading in media assets from the file system.
Fair enough, yes.
So this time it should look a bit smoother.
Are you doing compiling the shaders in the middle of the time demo here, or do you actually do all of your shader compiles at level load?
All of the shader compilation is done at the beginning when the renderer is initialized.
Okay, yeah,
So-
that was a common cause of stalls like that I've seen.
Yeah.
We do some of the compilation, we used to do at least some of the compilation later on during actual draw calls. We've reduced some of that as part of our Left 4 Dead 2 tuning, and so that can cause some significant hits if you accidentally trigger a compile during your level play.
Yeah, I think I have seen, maybe once I've seen it trigger a recompile for, I didn't know what reason. I couldn't reproduce it, so yeah, I didn't try to track that down. But yes, you can see that now this is running at 38.6 FPS, so the media loading does take some time there. So, okay. Anyone else? Okay, well, thank you for your time, and I hope it was enjoyable.
Thank you, Oliver, for your talk.